Assalamualaikum warahmatullahi wabarakatuh. My name is Abdul Haqeem di Akhyani. So today I'm going to talk about my project, which is Tenability analysis of occupants in single office room in Faculty of Engineering UPM. So I'm going to talk about the introduction to my project, and then later on I will talk about the my progress. Okay, now let me see. Fire can occur in buildings at any time, originating from numerous sources. Over the years, fire has continually causing fatalities, injuries and destruction of properties, mostly buildings and equipments. That is, Putra 2013 said. So the main cause of fire in office including electricity, rubbish and waste material, smoking, cooking, heating appliance and combustible material. Okay, now this is the example of some fire event in the office room. So let me see. You can see that there is severe fire event which produce some high density of smoke layer. Okay, Malaysia Fire Rescue Department of Malaysia say that during the 5-year period at 2011 until 2015, they reported that fire in office room have an average of 155 cases. So the critical causes that influencing fire incident on building is electrical and lighting equipment, which is 1,765 cases in 2011 and decreasing in the following year as there is only 934 cases in 2013. This is different when the statistic is compared to US Fire Department, which the critical cause that influencing the fire incident is cooking equipment. So Stanley, the Vice President of Electrical and Electronic Association of Malaysia, he said that a lot of poor quality material has flooded the market. Basically, common conductors for electrical cable are mainly made of copper and aluminium. However, when they talk about costing, usage of substandard wire are made of other metals is increasing widely, and this will lead to overheating. So this is the main cause of the electrical and lighting equipment causes that can cause a fire event. Okay, for the problem statement, tenability study for specific location is important as lot of lesson can be learned by doing it. Performing tenability study may provide guidance for occupants and firefighters in the case of fire occurring. One of the components of tenability study is by conducting evacuation analysis, which is based on tenability limits parameter, namely visibility, smoke layer and toxicity. So for the first one, however, the problem of occupants condition and lack of fire detection and suppression contributing the increasing in fire event, injury and death. The problem is studied with the tenability limits analysis in terms of time taken, which occupant can escape before it becomes life-threatening condition of or untenable in fire event. Second one is, moreover, tenability studies are mostly conducted in other countries. Therefore, there is a high need and concern in studying this research in Malaysia. By using the different type of office layout for lecture rooms, this research could be set as a benchmark for further study in tenability analysis on different parameters and finding. For example, for evacuation time, ventilation tactics, water application for other type of occupancy. Okay, so for the objective, the main objective is to determine the relationship of tenability criteria such as smoke layer, visibility and toxicity to the survivability of occupants, means lecturer in single office room according to the accuracy of B risk in predicting the probabilistic analysis. So for the sub-objective, to conduct the survey in 25 lecturers office room with different type of layout at Department of Chemical and Environmental, Faculty of Engineering, UPM, as a benchmark in collecting data for fire modeling. The second one, to carry out probabilistic analysis based on collecting data by using fire modeling of B-risk fire tool. The third one is to analyze the tenability criteria for occupant exposure in terms of time taken for occupant will be in untenable condition, particularly for single office room. Okay, for the literature review, for the first one is Wei Gao 2013 fire load in students' dormitory buildings. He believed that the type of room students grade and type of combustible influence the magnitude of fire load. So his finding and result: first one, conducted survey using the internet questionnaire in order to survey a larger number of students' dormitory building across the country. So the fire load density of all the survey building show a normal distribution with the mean value of 537 megajoule. The maximum value is 812 megajoule and the minimum value is 234 megajoule per meter square. So student grades also plays a significant effect on the composition and magnitude of the fire load. So they find that the main combustible item is wood and contributed over 50% of the total fire load. Okay, for the second one is MC Luo 1999 application of fire model to fire safety engineering. He proposed that fire models are essential tools for the purpose of the fire engineering approach using CFAST to determine tenability analysis for the fire safety system designed for very pier building. So his finding result is for the first one, using CFAST fire model to analyze the tenability criteria in toxic gases and smoke layer based on calculation of the fractional effective dose (FED). So occupants will become unconsciousness when the FED value reaches 1.0. To ensure the safety of occupants during fire, 0.5 is used as the maximum value of FED for a tenable condition. The FED value in the kitchen reaches 0.5 in 250 seconds and 1.0 in 320 seconds. If fire start in the dining area, the tenable time in this area is 650 seconds when the FAD value arrives 0.5. The evacuation time of the restaurant is estimated to be 525 seconds, equal to 8 minutes and 75 seconds. He concludes that the occupant in the restaurant can be evacuated safely. Okay, for the methodology, we have 5 steps. For the first one, survey on combustible item in the office room. This one, I need to make a checklist survey for the all 25 office room for the Faculty of Engineering in chemical departments. And then second one, they determine the total fire load density and heat release rate. This one, after making a survey, I need to determine the calorific value for each combustible item and then determine the fire load, and then I need to calculate the fire load density and finding the heat release rate from the journal, and then after that set up various model with compartment characteristic and fire design. This one using the dimension of the survey from the room and then set up from the various model, and then runs various simulation with collected data, and then data analysis in studying the tenability dynamics under probabilistic management. Okay, now we move to progress result. This is my progress. So for the first one is survey on combustible item in office room, and then I determine the total fire load density and heat release rate. Okay, for the survey on combustible item in office room, I have surveyed 25 office room by measuring and estimating the combustible item in each room. So there are 2 sizes of office room and labeled as small and big room. The small room are built with windows facing a closed building, while the big room are built with windows facing the outside environment. As all rooms were surveyed, they have the same fire detection and suppression system and ventilation system, which all rooms have one fire sprinkler and don't have any smoke detector or any smoke alarm. So the second one is all ventilation, which are windows and doors are in closed position during working hours. Okay, this one is the table of 2 sides of office room. The first table is the total floor area. So they have different total floor area because the first one is for small office room, which is 12.52 meters square, and for the big office room is 15.20 meter square. So for the total window area table, the total window area, both of office have the same area, which is 2.28 meter square. Okay, this one is the example of checklist survey for small office dimension and window dimension. And the second one is the example of checklist survey for big office dimension and window dimension. So this is the example of my work lah for the documentation. Okay, for this one, this is the picture is where both office room are located. For the number one is the site where all the small office room are located. The arrangement of the rooms is facing the center of the building. The second one is the site where all the big office room are located. The arrangement of the rooms is facing the outside environment. And for the star sign is the position of the windows of the small office room that facing the center of the buildings. Okay, for the ventilation system, both picture showing the windows which facing the center of building, and the other one is outside the environment for the windows. So from the checklist survey, the data recorded justifying that all windows and doors are closed all the time during working hours. So we are assuming that there are no ventilation system for all the office room if fire event is happening. Okay, for the fire detection and suppression system, from the checklist, the building are only providing a single fire sprinkler in each office room, a single fire alarm at level floor, 24 fire sprinkler at level floor, 3 fire extinguisher at level floor, and 2 fire hose, 1 with reel. But there is no smoke detector or smoke alarm provided either in office room or at level floor. So this one some of picture that I take at the floor, which showing in the office room there is only 1 sprinkler and 1 speaker only, and there is fire extinguisher on the floor, 1 fire door, fire hose reel, and there is no any smoke detector or smoke alarm. Okay, from the graph we can see that smoke detector will activate first. So for me, for my suggestion, for my opinion, smoke detector will generally activate considerably faster than heat activate device or sprinkler, and hence of great benefit for improving life safety. So when I look at the office, there is no any smoke detector alarm. So because when fire event happens, smoke layer will occupy the room first before the fire will spread. Okay, now we move to the fire load. So the combustible item were recorded into 3 groups, which are permanent fire load, semi-permanent fire load, and movable fire load. This one is how I distribute the survey from the documentation. So for the permanent fire load, the combustible item which I will categorize as the basic furniture and appliance that provided by Universiti Putra Malaysia. And for semi-permanent fire load, the combustible item which were categorized as the furniture of appliance that provided by occupants or lecturer and can be removed from time to time. So for the movable fire load, a group of combustible items such as papers, file boxes, books or thesis, which can be removed or changing in quantity every day. So this one is another example of my checklist survey for documentation that I do in my holiday. So this is example of the permanent fire load, semi-permanent fire load, and movable fire load for one of a small office room combustible item survey. Okay, this one is the table for the combustible item measurement. I take one example of a small office room measurement. So in the table we can see that I put all the item for the room and the dimension of each item, the mass, the total mass and the material of each item. Okay, for this one is the calculation of the fire load and fire load energy density. So from the table I list all the combustible item against, and I total up the weight and the calorific value of each item to get the total of the fire load for that room. So from the total fire load I will divide it with the floor area that I calculate before to get the fire load energy density for that room. So this one is one example of the small office room fire load energy density, which have the value of 605.44 megajoule per meter square. Okay, as we can see that the table show that the total fire load that I get from all the office, either for the small office room and for the big office room. So from that I calculate the average for both office room. So for the small office room, the highest total fire load is 17,144 megajoule, which is office number 5. The average for all is 8,804.7 megajoule, and the lowest one is 4,662.8 megajoule, which is office 6. So for the big office room, the highest one is 25,103.7 megajoule, which is office 2. The average is 15,978.2 megajoule, and the lowest one is 11,053.7 megajoule, which is office 6. Okay, for this one, this is the comparison of fire load energy density for all office room. So from the table I calculate all the fire load energy density from the formula, and I calculate the average too. So we can see that for the small office room, the highest one is 1,368.94 megajoule per meter square, which is office 5. The average is 703.01 megajoule per meter square, and the lowest is 372.33 megajoule per meter square, which is office 6. So for the big office room, the highest one is 16,051.56 megajoule per meter square. The average is 10,051.20 megajoule per meter square, and the lowest one is 727.22 megajoule per meter square. Okay, after I got all the fire load energy density, now I move to the heat release rate value. So for the heat release rate value, I need to find from the journal or internet value or review, because for the heat release rate we need to do the experiment to get the value for the measurement. So this is one of our limitation for this research. So after the discussion, we will use the previous research for the value of heat release rate of each combustible item. So we will find the average for the different journal. So this is the table for the heat release rate that I already recorded for the research. Okay, so that's all for the progress that I have done. So for the next step of progress, after finding the HRR value, the HRR value is very important for the BRI setup, because it will show the HRR profile for each room. So from that profile we can find the tenability limits in order to find to see the profile of fire spread and flashover. So it could affect the time taken for the occupant have before they become untenable to fire event. So the next step is to set up BRIS model and then run BD simulation, and then data analysis in studying the tenability limits under probabilistic measurement, which is we will see the profile of the smoke layer, the toxicity, and the visibility of occupants in terms of time taken before they become untenable to fire event. So this is my time frame for the next progress. So I will do the BD simulation on October and November, and starting the writing for the discussion, and prepare for the final presentation and fully thesis submission. So that's all for me. Thank you very much. Assalamualaikum.